Let me share the previous day document with you. I think that was our first day. We discussed these things. We discuss about the fundamentals, the tools we need to design a circuit, and we discuss about the basic gates. And finally, when we have a circuit, we try to write output Boolean expression. Then we did it. Then after that, we tried the reverse also. When we have an equation, when we have an expression, Boolean expression, then we try to draw the circuit. I think both ways you may be comfortable. If you have anything regarding to that one, then we can discuss it here. Otherwise, straight away we can move to the designing part. What do you think? Okay. Is it okay? Shall we take the challenge? Shall we try to design circuits? Okay, we can try to do the things. Let me share a new document. This is today lecture document. I think when we design a circuit, I think it's important to have some kind of idea about that, how to design a circuit like that. Then, okay, can you give me a minute? මේවට කොහොමත් මේකට බලන්න. චූටි නිකන් අඩිය හිලක් තියෙන ජාතිත් ඒවත් හදන්න පටන් මේ දැන් මේවා දැන් හදන්න
කරන්න බෑ හිතුණා අපිට. මේකේ නෑ මෙයා ඩ්‍රිල් එකකින් හී කරන්න කියලා හදුවා.
ඩ්‍රිල් එකකින් කරන්න එපා. අර හදන වෙලාවට පොඩි කැල්ලක් තියන්න. හදන වෙලාවට පොඩි කැල්ලක් හිලක් තියන්න. අඩියට පොඩි මේ ගල් කැටයක් හරි මුලින් බඩ කැල්ල චූටි කැල්ලක් තියලා අර ප්ලාස්ටික් පොඩි මේ කැම්බට කැල්ලක් තියලා ඒක කළා දාලා පස්සේ ආවට පස්සේ කැම්බට
ඔව් සිමෙන්තිත් අපරාධය. වෙන නටුවන් නෑ නෝ කරේ.
අයිය නැද්ද? මේවා
නෑ අයිය කඩන්න බෑ. කඩනකොට ගැලවෙන්නේ.
ඒක මේවට මේවා ටික ගාලා අදිනේට මේ ඔයිල් ටිකක් ගන්න. ඒකට ඉතින් මේක සෙට් වෙයිද දන්නේ නැහැ. පාටයි ඉතින්.
නෑ පොල් තෙල් ගාලා නෙමෙයි. ඊට පොල් තෙල් ගාලා තමයි මේවා ඉන්නවත් නැන්නේ නේ. සමහරවිට හයිරා විදිහ පොඩ්ඩක් තක්සු කරනවා ඉන්න ගැලවෙන්නේ නැහැ. ඒක ටිකක් ආයෙ හයියෙන් ගහුවම තොග්ගල කෑලි දෙකට ගන්න.
එහෙම නැත්නම් ග්‍රීස් ගන්න.
ඒක පාට නෑ.
ඔයිල් ටිකක් ගාවම හරි. පොල් තෙල් නේ අර එන්ජින් ඔයිල් ගාලා බලන්න මට මේක පාට අප්සෙට් වෙයිද දන්නේ. එන්ජින් ඔයිල්
හැබැයි මේවා ඒක ඊට පස්සේ එහෙම කරන ගමන් ගලවන ගමන් ආයෙ සබන් දාලා හොදන්න.
එහෙම නැත්නම් කරන්න තියෙන සාමාන්‍ය සිමෙන්ති වලින් හදලා අර මේවා දාන්න.
පාට ගන්න.
මොනවද අර දාන්න ටයිටේනියම්.
ටයිටේනියම් කිය තිබ්බනම් මට ගාන මොනවද තිබ්බේ?
ඒකට ගාන අඩුයි වගේ. ටයිටේනියම් වල මේ කලයක් ගන්න. අලු පාට නේ තෝරන කොමන්. හරි. Thank you.
දවල්ට එන්න.
Hello. Okay. Sorry for the disturbance. We have to discuss about the standard designing procedure. Then when we have a standard designing procedure, we don't have any problem actually that after discussing this one and after understanding the standard designing procedure that you can have any method convenient to you. You can apply any method, you can use any method to convenient to you. But anyway, that before that, before we start this one, I think it's better to follow the standard designing procedure. Okay, and shall we write that standard designing procedure? Okay, then let's take a small example. Then you can easily understand this one. Assume that you have a maybe it's very easy example. Then we have two entrances to this room. The one entrance is A. The other entrance is B. Okay. Then this customer is coming to you and telling that he's having a problem regarding the security of this room. Then he's having these two doors, and his security requirement is that according to his requirement, one of these dangerous conditions of the security condition is occurred. We have to turn on an alarm. Okay. Then his security condition may be when this door A open and B closed. Okay, that is the one condition, and other one is door open and B open. Okay, during this time also alarm should be sound. These are the two security conditions, and then based on that we have to make a circuit. We have to make a circuit, and this is the circuit we are going to make. And from these two sensors, we can take inputs here. Assume that we have fixed two door sensors there on top of the doors. Then from these two door sensors, we can identify whether door is open or closed. Okay. Then these sensors will produce that signal. And after that, we have an alarm here. Then we can turn on alarm. One of these conditions is occurred. Okay. Then to do that, for this one, when we follow the standard designing procedure, the first step is we can draw a block diagram showing all the inputs and outputs of the system we are going to build. Actually, this step is not a big step, not a very much useful required step. But anyway, that when you draw this one, you will realize that maybe what type of inputs are there, and how many inputs are there, and how many outputs are there. Okay, then because of that, when you have a complicated circuit, this may be useful step. Okay, here we are indicating that this is door A. From door A and door B, we have two inputs. This is A and B, and this is the output. We can say for this alarm, we say M. Okay, this is the circuit we are going to make, and this is the input side and this is the output side. Then first step is we have done. The second step, we have to prepare a truth table for the circuit or maybe system. For this circuit, we have to prepare truth table. Then with truth table, we are going to include everything according to the circuit. When you prepare truth table, that how many inputs are there, two inputs, A and B. Okay, then this is A and B. What is the output here? Output is M. We have single output column and two input columns. And what are the input combinations? 0, 0, 0, 1, 1, 0, 1, 1. What does it mean? A0 means though A is closed, B is closed. Here A closed, B open. This is A open, B closed. Both are open. Those are the all possible combinations we can find within this situation. Okay. Then here we say logic 1 is open and logic 0 is closed. Okay. Then like that, we can fill this. What are the condition he has given to us? Though A open, B closed. A open, B closed mean this one. This is A1 and B0. Here A1 and B also 1. Those are the two combinations we are receiving from his requirement. Okay, then A1 B0. Here A1 B0. At this A1 B0, A1 B0 alarm should be sounded. That is the one of the security conditions according to his requirements. The other condition is A open B open. Here also alarm should be sounded. What about these two? Both those are closed. There is no problem. A closed, B open. Again, there is no problem. Now we have prepared a truth table according to his requirement. Is it okay? Is it okay? Yes. Okay. Then third step. Now we have prepared truth table means. Now maybe the couple of minutes ago, this is our problem. He has given these things in verbal format that we have written it as a sentence. Then a couple of minutes ago, the problem is mentioned as a sentence. Now, after completing the second step, now we have included this entire problem into a table. We converted the entire problem into a table. Now, inside the table, we can see the problem. Everything is summarized to a table. Now, we'll go to the third step. What is the third step? Write Boolean output equation for the circuit. Then we have to write output equation for the circuit. Then how can we write output equation for this one? Then these are the ones. We have to consider only these things. But here we don't want to turn on alarm. But here we want to turn on alarm. Then we have to convert this one into a term. How can we convert this one into term? I'll write this one. This is, sorry. This is A, B bar. Why? A is 1, B is 0. Then we can say this is A, B bar. This one I can write. This is AB. Is it okay? Then why don't we write this one using operation? Here we have used AND operation to convert this one, to take this combination out from the table and to make a term here. We use AND operation, the red color one. But here in the light blue color one, we use this combination to be converted into a term. We use O operation. What do you think? Which one is the correct one? Here we use AND operation to write these terms. Here we use O operation to write these terms. Which one is the correct one? What do you think about these two? Yes, AND. Why AND? Because AND check. Both things are okay. Both things are correct. We want to check, not the one of the doors. If one of the doors is having this condition, one of the doors is open, then we can turn on alarm when we have operation. But here, we don't want to do that one. We want to check both those at the same time. Okay. Then the correct operation is AND. Okay. Then we can write output equation. But after writing this output equation, you will realize that definitely we use AND operation to convert this term. That is correct. Why? So now we can write our output equation. M equals, what are the terms? A B bar, that is one condition. The other condition is AB. Okay. Then this is one combination.
Excuse me, sir.
Yes.
If we use AND operation, then it's multiplication. No? In the truth table, 1:0 is 0. No?
No, here, Puta, that with AND operation, we don't think about that. It as multiplication. Multiplication is something else. AND operation is something else. In multiplication, you know that the meaning of multiplication is when you multiply 1 by 0, result is 0. But here, it's not multiplication. It's AND operation. With the AND operation, what we have here, when we take AND operation between 0, 0, output is 0. But here, I think whatever the thing you are telling with multiplication, it may be matched with this one. But multiplication and AND operation are two different things. Excellent. Accidentally, these two things are matching here, but don't get a confusion, don't get misunderstanding about this. Multiplication is exactly same as AND operation. It's two different things.
Okay, thank you, sir.
Excuse me, sir.
Yes. Yeah.
Sir, in the operation, can't we use A plus B instead of B bar?
No, here the problem, Puta, is that, can you give me a second? Hello? Okay, then actually that here why we are using this to catch up this condition. But what is this condition? Here, door A is closed, B is closed. But from the sensor, we are receiving 0 and 1. Then to identify whether door is open or closed, we use a sensor. This sensor is producing this 0 and 1, indicating that whether door is open or closed. Then why we are taking only these two conditions? This is the only combination. We have this 1 0. What is this 1 0 is? According to our customer, he's having two requirements. One requirement is he has to identify, he wants to identify whether door A is open and B is closed. Okay, when A open, B closed, it is A1, B0. That's why we take this one as this is the required combination, and this is the other combination. A open, B open. But when you convert this one into a term, this is A, why A is 1. This is B bar, why B is 0. That's why we write this way. A B bar or A plus B bar. But our question is which one is to take. But here we are taking AND. Why? With the AND operation will check both inputs are true. then and will produce 1. But O is not like that. When one of these inputs is true, O produces 1. Okay, I think you will realize that when I write this equation, but here, what is this? This is one condition. One condition means A open, though A is open and B is closed. What is this? This is A is open and B is open. Okay, can these two happen at the same time? No. Because of that, we have to combine this one using O. Why? Because if this one happens, O, this one happens, alarm should be turned on. That's why for this operation, we need AND. This operation, we need AND. To combine these ones, we need O. If one of these things are true, if one of these things, okay, try to understand this, one of these things is true, we want to turn on the alarm. But how can we take this one? One means this one. This is AB bar. Then we want to check these both things. According to this condition, both things are true. Okay, that's why here and here. Is it okay? Then what is the fourth step? Then draw the circuit using basic logic gates. Now, after completing this step, the third step, what we have done, we have converted our entire problem into an equation. Okay, then we have converted our entire problem into an equation. Then, after having this equation, then you know what to do. Why we have done this one? When you have an equation, you know how to draw a circuit using basic gates. Okay, shall we do that one? Now we have input A and input B. We want to convert this B into B bar. This one also. Then we can make these two terms. Okay. Then we make first term A B bar. And we'll make AB also. This is A. And finally, we can combine these two using a OR gate. Now, this is the output. It's going to the alarm. Is it okay? Now, this is what we need. And this is our solution. Okay. Then we can put this one here. This is our circuit. This input can be, they are coming from the sensors. And this one is going to, this is B, this is A, this is M. Is it okay? Now, what do you think? Okay, Lakshmi, why can't we use operation? But did you understand that why can't we use operation here? But did you understand that operation is the best one, the only one we can use to combine these conditions? When you want to combine these conditions, this condition and this condition, what we have to use? It should be O. Why? These things, if you use and here, it will never happen. Why? This combination and this combination at the same time, is it possible to have two combinations at the same time? No. Because of that, here we have to use O. This one O, the other one. Okay. Nimal O and. When I say Nimal O and, one of these two can do a job. But when I say Nimal and, both have to do this thing. Okay, here, then here we want to check whether do A open and B is closed. Not do A is open, O B closed. We want to check both things at the same time. Then here we are using O. This one, this is the correct one, and this is wrong. Then you have to identify here we use N to convert all the truth table terms into all the combination of the truth table into term, you have to use N. But to combine these terms with each other, we have to use O. Okay. Lakshmi, is it okay?
Yes, sir.
Okay. Yes, Anuji, actually, I couldn't do that one, that I'll upload these things to the LMS. I'll discuss with your, is it the data, when you log into the ICAM LMS, that you can access those things with the data free? Is it free to access ICAM LMS? Or that you have to use your own data? Okay, then there is no problem that whether where we have put these things. Okay. Anyway, that still that I didn't receive the LMS access to upload these things. But once you download the doc, yeah, after downloading it, it's okay. But otherwise, that you have to use your own data. Anyway, that I'll put these things there. Maybe normally I am putting all these things to the maybe my different repositories there, but anyhow that I'll give those access to the LMS. Maybe at least that I can give the link to the LMS, then you can go there and access it. Give me this week. Okay, then I'll upload this. I think yesterday I got an mail that it's mentioned that your examination may be during the end of November. I think still that you haven't had your circuit theory examination. I'll upload those things also. Okay, now it's time to start the real designing things. I'll give you a problem regarding this one, but anyway, it's not a new question. It may be related to the somewhat we have discussed maybe the couple of minutes ago. It's a kind of extension to that one. It's a little bit advanced version of the same problem. I'll share the document and I'll share the question, this one. Okay, you can try this one. Here we have 3 cells. Previously you had 2, but here we have 3. Shall we try this? Okay, then I think here we have to make a truth table. Then before that, did you identify that how these combinations we can take? This is A1 means A1. This is B0 and C1. Here A0, B1, C1. Here A0, B1, C0. In this case, A0, B0, and C0. Okay. Okay, shall we prepare a truth table? This one here we have 3 combinations. And for alarm, do we have specific letter? Bell E, yes. This should be E. Okay. And these are the possible combinations here. Okay. Then which conditions we have to? First one is A1, B0, C1, 101, 101, 101. Here, alarm should be sounded. The second one, 01, 01. Here also alarm should be sounded. Third one, 010. This one. The last one is this. So all other combinations, alarm should be kept quiet. Then we have to convert this one into terms. This is A bar, B bar, C bar. This is A bar, B C bar. This one A bar, B C. This is A, B bar, C. Is it okay? Then E equals C. Okay. Then final step, we have to draw the circuit using basic logic gates. Okay, sorry that I thought you didn't see this one. And I prepared this truth table. And for this truth table, these are the ones. And we have to convert these one into terms. Then after that, we have to write output Boolean equation like this way. And then we have to draw the circuit. Sorry that I have shared the wrong document. Previous one. Okay, then we can take these three. Then this is A, B, C. And we need A bar here. And we want B bar also. And we need C bar also. Okay, first we make this term. Okay. The second term. We need C bar. And B. And A bar. Okay. Next one. It's C. And B. And A bar. Okay. Then we C, B bar. And A. Okay. Then to combine these four, we can use 4-input OR gate. And this is it. Is it okay? Okay, then if you are okay with this, shall we try another one?
Excuse me, sir.
Yeah.
Can you please show the truth table for some? Okay, sir. Thank you.
Okay, then we can go to the questions again. Then this is the second question, but you can see the previous one. Straight away, the conditions are, all the conditions are given. But in practical situation, all the time that we don't have the conditions like this, but we can have the condition differently. Okay, then read this question and try to understand what we have to do. Okay, then here actually that I think it's not a difficult thing to you. Again, we have 3 inputs there, but only the thing that you have to understand the problem that it's these sensors will detect the position, and we don't care about that how these sensors are detecting positions and how they are producing outputs like that. We don't care about those things, but anyway, but we need, and those sensors are capable of producing outputs when the position is detected. Then the condition is the important thing, and when 2 or more positions are detected, 2 or more sensors are detected the position, then we have to turn on our alarm. That's what the question says. Okay, then output should be, this is output is named as L. Then we can prepare the truth table as usual. Here, then A, B, C, and L is the output. Okay, then what is the condition? 2 or more positions are here. No position, only one. Here 2 positions have been detected. Then this should L should be 1. Here only 1. Here 2, 2, and 2 or more. Because of that, this is also okay. And for all other combination, we put 0. That's putting zeros there is essential. Why? It indicates that these combinations are not belongs to our function. Okay? Because of that, we have to put zeros there for all these combinations. Then we can make terms there. This one, this is A bar BC. This is AB bar C. ABC bar and ABC. Okay. Then we can write final equation. Then L equals like that. Okay, this is the final equation. Then we have to draw the circuit. I think circuit drawing is not a problem to you, that when you have an equation that now you know how to draw the circuit. We can, if you are okay with this and circuit drawing is, if you don't have any problem, shall we quickly try the other question? Because we have only 15 minutes more. What do you think, that is it necessary to draw the circuit? Are you okay with that? Okay, then shall we try the question? But if you have any kind of problem, that please tell me, okay? Because this is a very important step, that if you don't have any of these steps, that if you don't understand any of these steps, that it's really difficult to go forward. And this is the third question, but anyway, that this is for another type of question, that here the conditions are not straightforward. Okay. In practically, that the practical situation, we have to extract the condition from the problem. Then sometimes that we very clearly we can see the conditions, that sometimes according to the problem, then conditions may be different. But here maybe the different way of expressing the problem here. Try to understand this one here, that when you fill the truth table, it's maybe tricky. Two conditions are there. Then depending on that, the filling of the truth table may be a little bit carefully to be done. Okay, shall we try this one? We have only 10 minutes. Quickly we go through this one. Then later on, the balance part you can do it later. Okay, this one is again, it's not a difficult question, but only the thing that the way they have mentioned the problem, that is the thing, important thing. And again, this one is also again this type of block diagram we can have there. I can straight away copy it here to save the time, but only the thing that we have different sensor names. And this is here, this is flow rate, pressure, and temperature. And output is M. And truth table, FPT. Okay, I'll take this truth table also to save time. Then there are okay, then FPTM, then FPTM, and we have what is the first condition? Then two dangerous conditions are there. Then first dangerous condition in when pressure and flow rate are low. When pressure and flow rate are low. Pressure and flow rate are low means F0, P0. Here F0, P0, but the temperature is 0, but it doesn't matter. Here temperature is 1. Here also we have flow rate 0, pressure 0. The other one, temperature and pressure are high. Here P1, T1, but we don't care about flow rate. Here also flow rate is 1, but we don't care. Pressure and temperature are high. Okay, then these are the four combinations we can have. I think the rest of the part you can easily do, and we have to convert this one into terms. And this is F bar, P bar, T bar. This one F bar, P bar, T. This is F bar, PT, and last one FPT. Okay. Then when we write final equation, first one F bar, P bar, like this. And the rest of the part you can do. Okay, we have taken couple of minutes from your time that I think you may have the evening lecture also. For the moment, I think what we want to discuss today that you have to understand that how we are going to do the designs, and this is the way we are starting our designs. And maybe the next day at the beginning we can have the small other, another type of question to be discussed. After that we can go to the important thing is you have to understand those things well. And if you have any kind of question, that next day we can discuss those things. Okay. Shall we finish the lecture today? If you don't have any question, we can wind up the class and we can meet. Okay, this one actually that what we want to do that this one first condition is, what is that condition? The flow rate and pressure are low. When the flow rate and pressure are low, alarm should be sounded. That is dangerous condition. But here 0 P0. But we don't care about the temperature. Temperature is not mentioned, but we do, because of that, we don't care about the temperature. Then only the thing here 0 P0, because of that, alarm should be, so that is dangerous condition. Here also F0 P0, because of that we have to consider it. We don't care about the temperature value here. Because of that, from that condition, two combinations will be covered. That's why we put 1 here. The last condition they mentioned here, the other dangerous condition, when pressure and temperature are high. Again, it's a dangerous condition. But here, pressure high, temperature high. But flow rate is 0, but we don't care. If these conditions are okay, then we have, that is dangerous condition. Then we have to turn on alarm. And here also, pressure and temperature are high. Because of that, we don't care about the flow rate value. We have to turn on the alarm. Only the problem you are having when you fill in this truth table.
Excuse me, sir. There it said that to consider the alarm is sounded before the dangerous conditions. No, so shouldn't we consider the other choices except, that means here the dangerous conditions are mentioned. No, so the alarm should be sounded before the dangerous conditions, means the alarm should be sounded in the safe conditions.
Yeah,
isn't it?
No. Actually, that before the dangerous conditions means that you have to identify the dangerous conditions. Then when the dangerous conditions come, suddenly you have to inform. Before means that maybe the couple of nanoseconds or maybe the milliseconds time that we can take a decision.
Okay, sir. Thank you.
Is it okay? Some of you have mentioned that to discuss the last part again. Is it okay? Okay, I'll show the question again. This one. Then normally that 1-0, when you think about the 1-0, that is the normal practice and normal sense we are having, that when that situation is there, we will take it as 1. When door is open, we will take it as 1. When the condition is there, then we will take it as 1. But if you want that, you can take the other way around. But then you have to mention it. Before you start that, you have to mention that door open, you are taking as a 0. But in general condition, we take when switch is on, we take it as 1. When the temperature is high, we'll take it as 1. Okay. Then the situation is detected. When we we'll take that one as 1. But if you want that, you can define it at the beginning. Before you do the design, you can define it. Switch is on equals 0. Then after that, you can do this reverse logic, the negative logic. Okay. Anything else? Okay, then if you don't have any question, we can okay, this is the truth table and this is the equation. Is it okay? Okay, then shall we close the session? Okay, let's meet on next week.
Thank you, sir.
Okay, then until that, stay safe and take care of yourself. Okay.
Thank you, sir.
Thank you, sir.
Participation. Okay, you're welcome.